Lesson 5.5, Trigonometric Identities. Now, grade 11, we're looking at an intro to trig identities. Of course, you'll be doing much more with this next year in advanced functions. So let's start off, I guess, with looking at the sine of 55 degrees on our calculator. So if we type in the sine of 55, we get this as our decimal. So we'll round that 0.8192, 0.8192. And we'll do the same thing with cos of 55, 0.5736. Now we're going to divide those. So 0.8192 divided by 0.5736. And as we divide those, 0.8192 divided by 0.5736, we get this, 1.481, or sorry, 1.4281 when we divide them. So the sine of 55 degrees divided by the cos of 55 degrees gives us this decimal. Now if I type in the tan of 55, look what we notice. We get the same decimal. Now when that happens, we can say that the tan of an angle, the decimal we get, is equal to the sine of the same angle divided by the cos of the same angle. And that is what we refer to as an identity. So the identity can be tan of any angle is equal to the sine of that angle divided by the cos of that angle. Now in the example here, I use 55 degrees. In reality, it could have been any angle. Okay, any acute angle could have been the sine of 21 degrees divided by the cos of 21 is equal to the tan of 21. Any angle that will work. So because it works for all angles, we call it an identity. The tan of the angle is always equal to the sine divided by cos of that same angle. Now there's a variety of different identities, and in the table here, we've listed some of them. Now in the first column, these are reciprocal identities, and we're familiar with these, right? We talked about these in 5.1, cosecant, secant, and cotangent, the reciprocals of sine, cos, and tan. So we're familiar with those. These ones, we just looked at now that tan is equal to sine divided by cos. And the reciprocal of that, cotangent, is equal to cos over sine. So you can see that for cotangent, we have two identities here. We typically stay with cos over sine for cotangent. And then over here on the right-hand side, we have what's referred to as the Pythagorean identities, where sine squared plus cos squared is equal to 1, 1 plus tan squared is secant squared, and 1 plus cotangent squared is cosecant squared. Now, normally, if we were in class, I would have you memorize this table. Well, the first three you would already know. So basically, it's just these five that you'd be responsible for knowing. But it's important to know those that we're able to perform our identities or our proofs later on. I did want to take just a quick second and talk about the Pythagorean identity. So sine squared plus cos squared equals 1. Obviously very close to Pythagorean theorem. You know, x squared plus y squared equals r squared, sort of thing. The reason why I want to talk about this is because this can be rearranged. For example, if I want to isolate cos squared, I can say that cos squared theta is equal to 1 minus sine squared theta. Right? I can just bring the sine squared over to the other side. Similarly, if I want sine squared theta, it's equal to 1 minus cos squared theta. So you can rearrange the sine squared and the cos squareds to isolate one of the two. Okay, and you can do the same thing with the other two identities as well. You can rearrange them if you need to. So as we move on, we're going to look at simplifying. So to simplify, we want to get it, of course, in lowest terms or as simplified as possible. So we have tan divided by sine. Now, one of the key things with identities is you always want to get everything in terms of sine and cos. Sine and cos everything. So if you have tan here, you want to get rid of tan. And we've just learned that tan is equal to sine over cos. So I can change this tan into sine over cos, and all of that is still over sine. Now, what you'll notice is I kind of put a longer line here for my dividing. So my tan sine over cos, I made that line for that fraction a little bit smaller just so that visually I know that this is on my numerator and this is on my denominator. So we have sine over cos divided by sine. Now this sine down here on the bottom, we know is really just sine over 1. So when we divide with fractions, we need to multiply by the reciprocal. So what that means is I'm going to take my numerator, which is sine over cos, times the reciprocal of what I have on the bottom, which in this case is 1 over sine. Okay, so I took the sine over cos, and because I'm dividing it by sine, we know that when we divide, we multiply by the reciprocal. So now we're left with this. And when we're multiplying, if you have a sine theta on top and a sine theta on the bottom, those can actually cancel out, and we're left with 1 over cos theta. Now we don't need to switch that back into reciprocal. Of course, we want to leave it as a primary trig ratio. So that's as simplified as we can get, 1 over cos theta. So you have to treat these when you're dealing with fractions as if they were fractions. You know, when you add them, when you subtract, when you multiply, when you divide, and so on. So we need to be aware of the fractions. Next, we have two brackets here, 1 minus sine theta, 1 plus sine theta. And if these were variables, if that was an x and an x, we know we'd be able to kind of FOIL those, right? We can multiply our two brackets together. And that's what we can do with identities as well. If we need to, we can actually FOIL the identities in terms of multiplying them together. So we get 1 times 1, 1 times a positive sine theta, negative sine theta times 1, and then negative sine theta times a positive sine theta is negative sine squared theta, right? Think of sine theta as if it was a variable. If that was x, 1 minus x and 1 plus x in our brackets, we'd be able to FOIL that no problem. So think of sine theta as a variable. So when we get here, we have a plus sine theta and a minus sine theta. Now when we put those two together, they kind of cancel out. So we're left with 1 minus sine squared theta. And we notice from the previous page that 1 minus sine squared theta is equal to cos squared theta. Okay? Moving on to C. Sine theta minus sine cubed. Well, in B, if we're able to FOIL with identities or with trig ratios, then we should be able to do the opposite. And the opposite of FOILing is factoring. So you can actually factor in identities as well. Now, again, if we treat sine theta as if it was a variable, and this was x minus x cubed, then that would be a bit easier, right? I know how to factor that. If I had an x and an x cubed, I can common factor out an x. Similarly, with sine, I can common factor out a sine theta. Sine theta divided by sine theta is 1. Sine cubed, and I divide out a sine, I'm left with sine squared. Okay, if I common factor, if I divide a sine out of both of those, put it in front of the bracket here, and I'm left with that. And again, we know that 1 minus sine squared is equal to cos squared. So sine theta, cos squared theta. And that's simplified. And if we have our reciprocals, as I've always said, we can't really do anything with reciprocals. We've got to switch them back into primary trig ratios. So secant is 1 over cos, and cotangent is the reciprocal of tan. Now, if tan is sine over cos, cotangent is cos over sine. So when we go from reciprocals to primary trig ratios, what we're doing is we're taking the reciprocal, or we're actually flipping the identity. Now, cos on the bottom cancels out a cos on top, and we're left with 1 over sine theta. So those are 4 examples of how we simplify identities. Okay, fractions, FOIL, factor, and flip, the 4 F's. Kind of give us some hints or some direction on when it comes to proving trig identities. So let's move on to actually proving trig identities. So in grade 9, if you remember, when you were subbing values in for a variable, once you solve for y, sometimes the teacher asks you to check. And the way that you would check, if you remember, is you would divide the equation to left side, right side. You'd plug your value in and make sure the left side equaled the right side to make sure that you were correct. Well, identities are essentially the same thing. We're going to take this, we're going to divide it into left side and right side. So my left side is cos theta, tan theta, all over sine theta. And my right side, of course, is just 1. Now, when it comes to proving an identity, you always start with a more complicated side. It's easier for me to simplify this than it is for me to go from 1 and then build up to get to this. And the whole purpose of this is to get left side to equal right side. I need to get both sides to kind of be the same. So again, a couple of hints along the way. Hint number 1, and probably the most important, is everything in terms of sine and cos. I don't want tan in there. So I need to get rid of that tan. And what I mean by getting rid of it is I can convert that into sine over cos. So I get cos theta times sine theta over cos theta in my numerator, and then that all over sine theta. When you do these, you really need to make sure that you're aligning your fractions properly. So because tan I'm converting to a fraction, this cos theta is actually up here with the numerator with sine. I don't want it down at the bottom. Because cos, we're kind of treating that like a whole number. And tan, of course, is a fraction. So this cos stays in line with the sine. And then we have sine down here on the bottom. So once it's written like that, I know that I can simplify this because I have a cos on top with a cos on the bottom of that fraction. So that can simplify, and those coses can divide. And when those divide out, I'm left with sine in my numerator, and I have sine in my denominator. And sine divided by sine is 1. So, and we can say, therefore, left side equals right side, and we've proven that identity. Moving on to number 3. Again, we're going to convert this into left side and right side. My left side is cos theta. My right side, secant theta minus sine theta, tan theta. So again, start with a more complicated side. Step 1, get everything in terms of sine and cos. So secant, I know, is 1 over cos minus sine theta times tan, which is sine over cos. So step 1, done. Now I want to see about kind of simplifying this. And I know that I can multiply these together, right? Sine times sine becomes sine squared. So I have 1 over cos minus sine squared over cos. So I can multiply the sine. We multiply like a whole number of times a fraction. You just multiply with the numerator. The cos stays in the denominator. So my numerator is 1 minus sine squared and over cos. Now I have the same denominator here, which is good. So I can actually subtract the two fractions. And I can put those together. So I have 1 minus sine squared theta all over cos. And again, we've mentioned this a couple of times now. 1 minus sine squared is equal to cos squared. So we convert that to cos squared theta over cos. Now we have a cos squared divided by a cos, kind of like an x squared divided by x. So cos squared divided by cos just gives us cos, which is what we have over here on the left side. So we've actually proven our identity, and therefore left side equals right side. And we've proven our identity. Some more examples to look at, because identities are one of those things where the more practice you get, the better you get at them. So number 4, it looks a little intimidating, but again, we'll break it down. Left side is just tan. And right side, we're going to need lots of space here. Sine theta plus sine squared theta over cos theta 1 plus sine theta. Now for a question like this, it's kind of difficult to know where to start. And again, it's all about simplifying this, right? Because we need to get this to be tan. So we want to simplify, we want to get smaller. So in the past, a lot of students think, well, why don't I multiply these two brackets together? Which if I do that, I'm going to end up with cos plus sine cos, which is going to be a mess. So the difficulty with identities is obviously knowing what that first step is and what direction to go in. And with this question, it's important to recognize that the numerator can be factored, right? We want to always go back to our 4 F's: fractions, foiling, factoring, and flipping. If you're looking for a direction to simplify, look at those 4 F's. So because I can factor the top, I have sine theta 1 plus sine theta all over cos theta 1 plus sine theta. And it's just recognizing that first step. If you can recognize that you need to common factor the numerator, then after that, this becomes a whole lot simpler because I have a 1 plus sine theta and a 1 plus sine theta on the bottom. So those can cancel, right? They're in brackets, it's contained. So because they can cancel, I'm left with sine theta over cos theta. And we know from the start of this lesson that sine over cos is equal to tan. And therefore, left side equals right side. And just like that, we've proven our identity. So a lot of these come from just recognizing what the step is that you have to do. For question 5, my left side, sine 4th minus cos to the 4th. And my right side is 2 sine squared minus 1. So with this one, people kind of wonder, well, which side is really the more complicated side? Is it the left side or is it the right side? They both look equally as complicated. And the reality is the left side is more complicated. And the reason why it's more complicated is because you have an exponent of 4. Whereas this side you have an exponent of 2. It's easier to reduce an exponent than it is to kind of add on and increase an exponent. So typically, if it's kind of a guess between the left side and right side, go with a higher exponent because you can simplify it. Now, the question is, how do you simplify exponents? Well, what we need to do is think back to our 4 F's. Fractions? No. Foiling? No. There's nothing to flip, so it means we need to factor. Now, how do we factor this? Well, first off, we have to remember all the way back to Unit 2 to our 5 factoring methods. And if I gave you a question like 64 y to the 4th minus 81 x to the 4th, we'll say, and I asked you to factor that. 2 terms separated by a subtraction sign. Difference of squares. Square root the first term, square root the second term. So for question 5, this is a difference of squares. Now in the past, students say, well, how am I supposed to know that? Well, factoring is one of those F's. So when you want to look if you can factor it, it's more than just common factoring. You could be sum and product, it could be decomposition, it could be a difference of squares. So if I square root these, I get sine squared theta minus cos squared theta and sine squared theta plus cos squared theta. Remember, difference of squares, they give you 2 brackets, one's a plus, one's a minus. Now, as I look at this, something kind of pops out at me, which is the sine squared plus cos squared. Because going back to our first page, with Pythagorean identities, sine squared plus cos squared equals 1. So this becomes 1. Sine squared theta minus cos squared theta. I'm just going to put a 1 in there so you know I've switched that to 1. In reality, we don't need to write it. It kind of disappears. So we're left with sine squared theta minus cos squared theta. And if you think, that can actually be factored again. Difference of squares, right? I can square root a sine squared, I can square root a cos squared, and I can factor this further. But with identities, you always need to look at where you're going or where you need to get to. And if I look at my right side, because this is what I have to be equal to, I need to get here, and here I have a sine squared. Well, I don't want to get rid of my sine squared here because if I factor this, I'm going to be left with a sine and cos. But I need a sine squared. So I'm going to leave that sine squared there. But again, if I look at my both sides, I have a cos squared here, and I don't on my right side. So somewhere along the way, I have to get rid of the cos squared. And how can I get just rid of cos squared? Cos squared is equal to 1 minus sine squared. So what I can do is sine squared minus, now for cos, I change that into 1 minus sine squared, right? I have my subtraction sign, the cos squared becomes 1 minus sine squared. Now I bring that negative into the bracket. So I have sine squared minus 1 plus sine squared theta. Sine squared plus sine squared, 2 sine squared minus 1. And therefore, my left side equals right side. So it does take some thinking. And as you can see, no 2 questions are the same. So it's through practice, through thinking, going back to those 4 F's, what can I do along the way to get left side equal to right side? Question 6, I think it's easy to see that the left side is more complicated side. So for left, we'll write it down here. And my right side, because we're going to need lots of space here, I put the sine squared over here. So step number 1, everything in terms of sine and cos. Get rid of the reciprocals, get rid of tan. So we will make this secant, change that to 1 over cos times sine over tan. I'm going to change that to sine over cos. And cotangent, I'm not going to worry about switching that to 1 over tan because I want everything in terms of sine and cos anyway. So cotangent, we'll just make it cos theta over sine theta. So step number 1 is done. Everything in terms of sine and cos. I'm going to simplify my numerator because 1 over cos times sine just becomes sine over cos. And sine theta over cos theta plus cos theta over sine theta. Now, when we mentioned fractions before, I said if you have a fraction on the bottom, we just flip it and multiply it with the top. But the problem is I have 2 fractions down here, and I need to add them before I can flip them. And when it comes to fractions, in order to add them, we need to have a common denominator. One has a denominator of cos, the other has a denominator of sine. So in order to get them to be the same, I need to multiply this first fraction, top and bottom, by sine, and this fraction, top and bottom, by cos. So if we remember our numerator up here, sine theta over cos theta, just put my equal sign here. Sine times sine becomes sine squared over sine cos plus cos squared over sine cos. So now I have a common denominator and I can add them together. And if we look at the numerators here, sine squared plus cos squared equals 1. So that becomes 1 over sine theta cos theta, because I can add those together. Sine squared plus cos squared is 1. And then sine cos becomes my denominator. Now that I've added those and I only have a single fraction, now I can flip and multiply. So sine theta over cos theta times sine theta cos theta over 1. The cos on bottom cancels out the cos on top. I'm left with sine times sine, which is sine squared. And therefore, left side equals right side. And then a couple more examples here, just to finish off. Again, question 7. I'll start with our left side. Cos squared plus sine squared all over cosecant squared plus secant squared. And the right side is sine squared theta times cos squared theta. So we'll start with our left-hand side. Cos squared plus sine squared, it's 1, right? It doesn't matter the order. Cos squared plus sine squared plus cos squared. So we're left with 1 over cosecant is 1 over sine squared, and secant is 1 over cos squared. All right, remember from the F, flip. We want to flip our reciprocals back into our primary trig ratios. Again, just like the previous question, I have to get a common denominator. So I'm going to multiply this top and bottom by sine squared. And this fraction top and bottom, I squeeze it in there, by cos squared. Don't forget about this numerator of 1. A lot of times students are working down here in the denominator. They forget all about the numerator, and just forgetting about that as you move on, you won't be able to get left side equal right side. So we want to make sure that we have everything with us as we move on to the next step. So this now becomes cos squared over sine squared cos squared plus sine squared over sine squared cos squared. Sine squared plus cos squared is equal to 1. So now we have 1 over sine squared theta cos squared theta. And again, the rule with fractions, the numerator times the reciprocal of what's on the bottom. And the 1's can cancel, and we're left with sine squared cos squared. And therefore, we have left side equal to right side. Question 8, our last one, left side, cos theta, cotangent theta. Right side is 1 over sine theta minus sine theta. Now again, kind of tricky to figure out which side to start with, left or right. The right does look a little bit tougher, but everything's already in terms of sine here. On this side I have cotangent, which I can convert back to a primary trig ratio. So I'm going to start with the left side. So cos theta, and cotangent, if you remember, is cos theta over sine theta. I multiply those together, cos squared over sine. And again, if I look left side, right side, I have a cos squared here. I don't have any cos over here, which means I need to get rid of the cos. And I know that cos squared is equal to 1 minus sine squared all over sine. Now, we notice we're close, but we're not exactly there. So, what if we make that into a fraction? What if I had a fraction that was 3 plus 7, and I made that all over, say, 13? Now, if I separate that, and I make that 3 over 13 plus 7 over 13, nothing's changed, right? This and this still mean the exact same thing. I'm just separating it into two different denominators, or two of the same denominator, and putting the plus in between. I can do the same thing here. I can take that denominator and kind of work backwards by splitting it apart. So I can make this 1 over sine theta minus sine squared theta over sine theta, right? It's still the same thing. I've just broken it and separated the two numerators. And by doing that, I have a sine squared divided by sine. So I now have 1 over sine theta minus sine theta, and therefore left side equals right side. Now, there are a couple of things I did want to mention at the end of this. Number one is common questions I always get from students. Can I work with both sides? Can I do some on the left side, some on the right side, as long as they meet up and equal each other? And the answer is yes. Now, you should be able to only work with one side. There shouldn't ever be a need to work both. But if you get to the point where you need to work on the other side in order to get the two identities to match up, then by all means you can. Down here at the bottom, I have included some tips. Start with a more complicated side, everything in terms of sin and cos. No reciprocals, no tan. Then we look at our 4Fs. So I'm looking for, can I factor? Can I convert something into a fraction? If it's a reciprocal, I'm flipping that to a primary tree ratio. Can I FOIL? Can I factor? So in addition to that, we follow BEDMAS. You multiply first before you add or subtract. Okay, so that is kind of the direction we're going in. The textbook questions on page 310, there's a lot there because this kind of, you get better with it with practice. And again, as I mentioned at the beginning, there is a lot of identities in advanced functions as well. So just getting that practice to kind of go through it. You will likely struggle with some of those in the textbook, so go back and take a look at some of the solutions that are posted as well so that you can kind of see, because it does take a fair bit of practice.